WarmlyYours. Hi, everybody. I'm pointing at the screen because I'm saying, there's our screen. We're ready to go. Welcome to today's webinar. I'm Scott from WarmlyYours, and this is
Anatoly.
And we'd like to thank you so much for coming today. I'm going to get us off the screen and go ahead and get our presentation on so you can see what we are going to be discussing. So I just need to get rid of myself a little bit more here. So hold on one second. There we go. So what we're going to be talking about today is getting your basement winter ready with electric floor heating. And we've got a lot of good information coming your way. So please buckle down and get ready to follow along. And we have a section here on our screen that talks about questions. If you have any questions, you can enter them at any time just by clicking the Ask a Question section there on our website on this program. So let's go ahead and get started, and let's go over what we're going to cover. We're going to cover floor heating for basements. That's the draw today. And for you folks that may not live in an area that has a lot of basements, you can still watch along because a lot of this information is also very good for rooms that are over unheated spaces. So you can move a lot of this information into that sort of setup because it'll be very valuable for those type of rooms, like bonus rooms over unheated garages, stuff like that, rooms over crawl spaces. So we've got a lot of different things to talk about. We have tile floor, floating floors, also controlling the floor heating system. So let's go ahead and get started. So Anatoly, tell me the difference between a normally heated basement. And for you people that don't have basements, you don't have to deal with this because you normally have floor vents in your floor. But in a basement, a lot of times in the Midwest, the air vents are actually overhead. So what are the two things that you see here on this slide?
Definitely great slide, great comparison of radiant floor heating system and the forced air heating. So the picture down below, the image down below shows us the forced air heating system. And that section on the right kind of shows that air vent that Scott mentioned at the very top, and eventually the hot air is blowing out there. The problem with that type of approach is, of course, hot air rises. And especially if you have those vents right at the top, that air may never even reach the floor level. So it blows out there, kind of circulates around at the top section of your room, and eventually escapes through the gaps and goes to the higher floors, stairway. Just pretty much getting out of that basement before it really warms up that basement. And of course, radiant floor heating that we show more towards the top there, you have those heating coils right in the floor. The floor gets warm. The floor radiates that heat into the whole room, into all the surfaces, into all the objects. That's why you get a nice average heat throughout pretty much all surfaces in that basement versus, again, forced air heating where you see that blue and red section on the left. You're really half of your room stays pretty cold while the top, the ceiling and all that section stays warm.
Right. You're heating about 40% of the air in your basement with the forced air heating system, and you're heating 100% of it with the the radiant floor heating. So it really makes a lot of sense in a cold surface like a basement to have a nice heating throughout the room. So you may be asking yourself, why electric heating? Why not something else? And why don't you go ahead and tell us about why to use electric instead of hot water or something else like that?
Sure. First of all, floor heating can really help by providing that efficient way to warm the basements. You don't need to install any of these expensive pumps and boilers or any additional equipment like in hydronic radiant heating. You're not going to raise your floor. You're going to really have that installation nice and smooth. And again, going back to the previous slide, that heat will be nice and evenly radiating throughout the whole room, throughout the whole floor.
Yeah, the thing is, you don't have to buy expensive pumps. You don't have to worry about installing pipes, because if you put in pipes in your basement, you're going to have to raise your basement floor 3 or 4 or 5, whatever inches higher than you would if you just use electric floor heating. So the thing is, if you don't already have a boiler, it makes a lot of sense not to install a boiler to put heat into one space. And that's what's so great about electric floor heat. You just get usually the power's in the basement anyway. That's where your circuit breaker box is a lot of times. And it's right there. So you don't have to worry about running cables or hot water tubes, from one end of the house to the other. So the reduction in the floor height, the reduction in cost of the pieces that you have to buy, and it's much, much easier to lay an electric floor heating product out on a floor than it is to install heating tubes, right?
Yeah.
So let's go ahead and take a look at our next slide, and that is, why should we have a winter ready basement, and why is it so ideal?
First of all, the big thing is it definitely helps to add the value to that basement. You will increase the comfort in that area. You're going to bring more people there. It's just the people going to start using that room more and more and more. So you can really, spend more time there, and specifically in those colder months, renovate, add whatever you want there, and start using that space finally.
And even if you have a small family now and all your children are gone, they do usually come back during Thanksgiving or Christmas, and this allows you a perfect way to get heat into this space without investing a lot of construction time to make this flooring put in there. So it does make this a great situation for a basement, because with electric heat, you can use it as a zone. So you just, when no one's down there, you just turn it off. You don't have to worry about heating the entire house like you do with hot air. So
Sure.
If you have a forced air system, you're blowing hot air throughout your entire house. If you're heating the basement with electric heat, when you're not in the basement, just turn the power off. And then you're going to save money, because then you're not trying to heat the entire house. Like in my house, if you want the basement to be 70, it ends up being 75 to 80 upstairs, because as we look, the hot air blows, and it goes right back up through the staircase up to the floors above. And so your floors upstairs are hot and your basement's comfortable. Well, that's not really a good trade-off.
Sure.
For the other people who are staying at your house who are sweating like crazy upstairs, so the people in the basement can be comfortable. So what's the first part of getting this thing underway?
In WarmlyYours, we have a pretty easy approach for that. I like to call it as easy as 1, 2, 3. You send us a sketch of the basement or room you're planning to heat. Our design team prepare a nice and easy to read, easy to use, customized smart plan that includes all the installation information, all electrical information, so your installer knows what to do. Your electrician has all the information about the electrical preparation. And then when it's time to install the product, you follow the plan. All the dimensions are there. Lay down the heating product, or it's one heating product there, and it's ready to go.
Yeah, it's a fount of knowledge, because we get questions all the time. Hey, I'm thinking about installing this stuff in my room. How much electricity do I need?
Sure.
What product goes in here? If you've never done this before, why don't you let us do it? Because we do it all the time. We do it every day of the year. So we know how to lay this out. We know how to make it so it covers the most usable area in that particular room. Then we can tell you at no charge what the amp draw is, what type of breakers are going to be needed, all that stuff. We'll figure it out for you. So you don't have to sit there and go, okay, I'm brand new to this. How do I figure this all out? Just let us do it, because it's much, much easier for us to get that done. Now, most of the time, a basement, at least in the Midwest, is going to have a slab floor. How does a cement or concrete slab affect the heating of this area?
So slab will naturally be colder in the winter. Even if you have the edge insulation installed around the slab or so, still, it's winter, temperatures are low, that concrete slab will be really cold. We never want to have the floor heating system to be installed directly over that slab, because all that heat that will be generated by the system going to be transferred down into the slab, and maybe just a small percentage of that will go and heat your floor. We definitely want to avoid that, because then the system becomes just inefficient. And how we go around that is we adding the insulation like cork or Cerazorb that you see on that top part of the screen. And that's the insulating material. That's the underlayment that goes down first onto the slab. And then the floor heating beam is installed directly on top of that material. So it acts as that thermal break, or pretty much a barrier between your cold slab and the warm part of the floor that you're actually heating.
What I want to do is I want to point out on this picture, You see these red things? These are the actual heating wires in the system. Well, these wires are not, they go here and then they disappear. If you look, this one goes here and then it disappears. This one goes here and then it disappears. There is wire going through this area of the picture. The secret is this wire in this area is laying directly on the concrete slab. So all the heat, or most of the heat, being generated by those wires in this area being sucked down into the slab. If we take a look here, you can see the temperature differences between here. We've got 75 degrees in this area and 79 degrees in this area. So what this means to you is this means that your floor is going to get warmer and it's going to heat faster if you have this product on here. So this is a great proof of the importance of using this product over a concrete slab. Now, we get phone calls from people who don't put this down. And those people sometimes say, well, my floor gets about 73, 74, maybe 75, but it doesn't get any warmer. I've let it run for 8 days in a row and it won't get over that temperature. Our first question is, did you install the cork or the Cerazorb? And they're going to say,
it was not installed.
Right. So what happens is they have, and if you ever read our installation manual, and you really should because it's really interesting, is in the book we say, if you do not put this product down, this insulating board, you can expect to have floors that aren't cold, okay? If you put this product down, you'll have floors that are warm. There is a difference between not cold and warm, obviously. And if you're going to go to all this trouble to heat this space, you might as well get the product that's going to make it feel warm. So if you don't put it on, it's going to take the chill off the floor. If you put the products down, it'll actually feel warm. So we can't talk enough about this product when it comes to concrete and cement slabs. So I love this slide. These tools are very inexpensive. And tell us what each one is and what they do.
Yeah, great. I like that we say that tools are really not expensive at all, but the amount of money that they can save is just, we can describe that. Yeah. So the tools we have here are the digital multimeter, the device with a yellow frame kind of, and the circuit check down at the lower section of the slide. So let's start with the multimeter first. That's the tool that you're going to use to test the resistance of your electric heating element before, during, and after the installation.
How far before should they test it?
Ideally, I would test the system first time the product just arrived, after it's being shipped, just to make sure it was not damaged during the shipment or anything like that. So test it right when it arrived or when you got the delivery. Test it right before you start laying down the system, just a dry layout onto the subfloor. So, and then it's always good to kind of periodically test before and after every major step of your installation. So before you start maybe pouring self-leveling cement onto it, before and after you start to install tiles. This resistance test will show that the resistance of the system, the ohms of the system didn't change. There is no short. That will be a clear indication that is good to go. Mm-hmm. The product is good to go. And the circuit check is a perfect tool to just monitor the system while you're working with a tile installation, or maybe while you pour in the self-leveling cement. When you physically just cannot test and install all at the same time, the circuit check will just make a noise when there is some sort of damage to the system. So great monitoring tool will give you a noise alarm when something is going wrong.
Can I just get this instead of bothering with this thing?
Not a good idea, because the circuit check, once again, it's not a testing device, so you cannot get any value out of it in terms of the ohms value, so you don't see what resistance is. So your system may have some resistance, the circuit check may not trip, but that resistance would not be correct. So not the best tool for your final testing. Multimeter is the device for that testing and the final confirmations.
What are some hints about getting a digital ohm meter? Should I go out and buy maybe $1,000 unit or $12,000 meter? And should I get an auto ranging meter? Does it have to be really big? I mean, what color should it be? What kind of thing do we need to look for with this product?
We don't really need any specific, expensive device or anything like that. What we are looking for would be, number one, it should be a manual ranging meter. So just similar to the one you see on the picture where there is a dial on the front and you can just select the right range. So you can manually select the resistance range that we want to test the system into. It definitely should be a digital multimeter, so with a digital screen, so it reads the actual value. You don't need to kind of guess and play with that needle there. And we want to make sure it's not a self-ranging meter, and we don't need an expensive meter. Basic digital multimeter with a manual range selector on the front that you can probably easily find in the vicinity of $10, $15, $20 max. That would be a great tool to use.
Yeah, they're fantastic tools. You can use them around the house. But you are not going to be able to do an installation of the floor without this item. So just go ahead and get it. So let's go ahead and look at our next slide here. And what are some important things we need to do at the stage before we do anything? What are we kind of setting the picture up here for us?
We want to first of all make sure that the subfloor is nice and leveled first. Of course, we're showing here on the picture just kind of even out some maybe angles or sharp edges or anything like that. But ideally, if it's potentially unleveled floor, so you really want to level it first. You don't want to install the system and then level the floor, because then you may get uneven heat, because you may have the sections where there's a lot of material on top that will heat up slower and maybe cooler temperatures. And the sections with less material, these will heat up faster and get to a warmer temperature. So level the floor first, make sure it's nice and uniform. Then your next step would be, of course, to attach the Cerazorb or cork insulation material to prevent any of that heat loss. And that's your first step of the installation. So anytime you have questions about something, give us a call. Our tech support is 24/7.
Yeah, if you have a question and you're in the middle of the installation and you go, I need an answer to this before I can continue on, call us up. That's what our installation support phone number is for. If you're in the middle of doing something and you can't continue without calling us, call us. It's no charge. So let's go on to our next slide, and let's start talking about tile floors. So when it comes to tile floors, what are some of the benefits of tile floors in basements? Because it seems like they'd be awful cold.
They will be cold if you don't install floor heating for sure, but having the floor heating added to it really makes me want to change to tile floor in the basement. So yeah, I mean, you're having a great look. You're not going to get that frigid temperature because now it's going to be heated. It can easily accommodate those different varying humidity levels. And for the rooms with the plumbing, tiles just simply can make that worry-free and clean-free and, installation, and you should not worry that much if there any leakage or any flooding happens there.
Yeah, it's very, very easy to clean. It's great for laundry areas. If you have an overflow like I just did a couple weeks ago, tile is much, much easier than cleaning up, say, carpeting, or a flood in a laminated room is another thing. And we did have a question that since we're talking about water here, I was going to save this question to the end, but I think now is a good time because we're talking about an area that can get flooded. Misty had a question for me, or for us. Temp zone, what happens if the basement floods? So if the basement floods and you've got water everywhere, what do you need to do? And I think it's important that we figure out, if you ask us that question, is to find out if you have tile in your basement or if you have carpet or a floating product. So what would they do in this case if they flooded this area with the tile?
If that would be a tile floor, we would use our Tamzone product most likely here, and we're going to talk about that in just future slides. But Tamzone product is completely waterproof, so if it's installed correctly, really what you want to do is just disconnect the system, disenergize the system, make sure either the breaker is turned off. Ideally, you want to just turn off the breaker. That would be the best way. Wait until the subfloor and just the floor is completely dry. Would be a good idea to do a quick resistance test if you have the meter. This way you can ensure that there's no problem with that. And, if it's all dry, Ohm test shows up fine, that's going to be a perfect time to, test it out of the system. It should be all good. I
wouldn't use the electric floor heat to dry out the floor because you need to make sure the floor stays in good condition. Now, if for some reason the floor floods and it's underwater for 3 months or 6 months, that may actually affect the construction of the floor. The tile may start to delaminate. The thin set inside may start to fall apart. It may start to delaminate. It may start to flake off, stuff like that. If your subfloor and flooring is beginning to fall apart, that's the case where the wire is actually built into that flooring. So if your flooring has failed, it can cause the heating to fail. We're talking like a temporary flood. Let's say it floods and you get a big pool there, you know, like a 10-foot puddle, and you go down there an hour later and clean it up. That's probably not going to ruin the construction of your floor. But if this floor is underwater for 6 months, the construction, the makeup of that floor is going to be compromised. And if that flooring fails, if that subfloor fails, that failure will take the wire with it. So that's one thing you want to keep in mind. So not necessarily the water will ruin the electric heating, but it may ruin the flooring and the structure enough that if the structure fails, it can damage the wire. And that's what we talk about. Stuff starts breaking up, and if the wire is embedded in thin set and the thin set cracks and goes like this, it's going to shear the wire. There's nothing you can do about that. So that's a big difference between a temporary little flooding or a little water damage as opposed to months underwater. Now we're going to talk about later another product that we use to heat hardwood, a floating hardwood, and for carpeting and for laminate, that sort of product. And if that area floods, we'll talk about it, but I don't want to talk about it right now because we don't even know what it is yet. Yeah. So let's just go ahead and save that for a little bit later. So let's talk about right now, since we know we're not going to be talking about laminates, floating products, carpet. Let's talk about heating for tile.
Right. So we have quite few different types of temp zone product. That's our generally that's our product for any types of flooring. You can really use it with any flooring, since that product can be just covered with thin set or covered with a self-leveling cement. So you're just getting that nice flat surface to install any flooring material. And in this temp zone product line, we have flex roll that are shown right on the top. That's that cut and turn mat that can be designed per our install plan and fit into any room, any shape really. There is also temp zone cable. So that's just your loose heating element, loose cable that you can install using the plastic strips or the membrane, and just again, per installation plan, fit into any room, any shape. We have custom mats, we have easy mats. Those are just some additional products that can be used depending on maybe how large the area is or how custom shape coverage you want to achieve.
Now, this product, the most important thing to remember about this product that's designed for tile is that it must be embedded in a cementitious underlayment. So it needs to be buried in thin set, or it needs to be buried in self-leveling. This is not a product that's designed to work in the open air. So if you see these two products, assume that they're going to go under a cement type of covering. So let's talk about installing the floor heating with tile, doing a cable job.
Right. So with the cable job, like I mentioned before, and like it's shown here right on the picture, we, as one option, we can use the plastic strips or plastic guides that will be used to kind of space the cable. The good thing is on the smart plan, if your smart plan is designed specifically for the cable installation with the guides, we show even where to position those guides so you can just run the cable. We indicate what spacing to run it into. So like this is your typical, looks like that's a 4-inch spacing that we're doing on the install. So cable, you lay down the guides. That's going to be your pretty much first step. And then just start running that cable per the installation plan between the guides, between the strips, using all the length of the cable. And then the next step, of course, is going to be to cover it in a self-leveling cement or thin set.
So tell me about the phone calls that we get from people that don't use masking tape. What is masking tape used for here, and why is it so important?
Masking tape is like one of the best materials sometimes, right? The masking tape will definitely need to be used in this picture in the very end when multiple runs are done, because as you can see on the picture, we're not trying to like string that cable and keep it at some super high tension so it just like a string on the guitar. We just loop in the cable, making sure it's at the right spacing, and In the very end, we just want to run the masking tape across, so perpendicular to the direction the wires are running, maybe every 2 or 3 feet, just to prevent that wire from floating to the top, especially when you're pouring the self-leveling cement later on.
Self-leveling cement is very, very dense, and anything other than self-leveling is going to try to float to the top surface. We get calls all the time by people that forget to use the masking tape, and now all of a sudden they've poured their self-leveling, and in the middle there, if you take a look at this, is about a 10-foot span.
Yeah.
The edges are under the self-leveling, and the span in the center is at the top of the self-leveling, which means now that they have to cover the product again with self-leveling because it floated to the top. So that's one thing you always want to make sure of when you're using self-leveling. Anything below it's going to try to go up through it. So you need to use the masking tape to hold that wire down. So let's take a quick look-see at the cross-section of this cable install. So what do we see here?
So you should be already familiar with those first few layers. So concrete slab is, eventually your foundation. That's where we're starting from. We spoke about the Cerasorb. So you use the modified thin set and then install the Cerasorb. That's our synthetic underlayment material that acts as an insulation here. And just like you saw in the previous picture, then you attach the strips, start running the cable onto it, and cover the strips and the cable with a modified thin set or self-leveling cement, depending on how the installation goes. And then the tile will be installed on top with another layer of thin set.
Now, one thing we didn't mention about installing the Cerasorb is the Cerasorb, you're going to need to go out and you're going to need to have a roller, because the roller, the Cerasorb needs to be put down with an 1/8-inch V-notch trowel, the modified thin set, 1/8-inch V-notch trowel, and then you need to put the Cerasorb down in it. You want to stagger it so it's like brickwork, because you don't want a bunch of seams going every which direction. And then once you get it on that, you want to roll it down to get your good adhesion. So anywhere between a 30 to 50-pound roller is going to be necessary when you're installing that Cerasorb to make sure you get a good adhesion. Otherwise, you might have a problem with it if it's sounding hollow if you don't get it down there real well. So let's take a look at this. Let's talk about this slide, the picture, and what is the product that's being installed here.
So here we're doing the same type of installation, but we are using the Temp Zone Flex Roll material. So this is the product that usually comes in a 1.5 foot or 3 foot wide mats. And on this picture, you can see 2 runs of the same mat that are just running next to each other. So the trick how you cover that whole room, you just get in one long mat, you run it back and forth by cutting the mesh, no cutting the wire, and covering the whole thing again with a self-leveling cement. So same thing with a smart plan. We show all the detail, what's the length of each run, how to cut and turn it. If there would be any sort of angled or some small area or section that needs to be covered, you can use a free-form wire out of the mesh, still cover it up. Perfect product to work for really any application.
Now, this entire product is going to try to float here. Remember, we've got self-leveling going down. So we need to make sure that this is adhered to the floor very well. If you look at the photo, you'll see that it's cable side down. The mesh is on top. We get that question all the time. Which way does it lay out? Cable side up or cable side down? Well, if you lay it out cable side up, that leaves the loops at the end. If they're not attached to anything, they can go like this. They can work their way up on the edges. And since we're covering it with self-leveling, they're going to try to do this. So the edges, you may see each loop at each end or along each side, you may see that it's kind of tried to raise up on the edge. The secret here is to make sure that you use a stapler to go into the mesh. Never, ever staple the wire, because if you staple the wire, you'll ruin it. And what you do is you either use staples in the area, the mesh where there is no cable. So you hold that mesh down, and by holding the mesh down, you keep the wire from floating.
Right.
So it's very, very important that you get those staples in everywhere to keep those loops at the end from trying to raise up. So you may see every once in a while, you may get an installation plan that shows one area where you have to actually turn the wire side up, but usually that's followed by the rest of the room is then installed with the wire side down. So if you looked at your room and you go, 90% of my floor is installed wire side down and 10% is wire side up, that's what it's supposed to be. Now, if you look at your floor and go, 95% of this is wire side up and only one small part is facing downward. Well, you did it backwards. So that's one thing you want to make sure of. When you're doing self-leveling, that's why it's so important to get the wire side down. You can also use hot glue to hold this down. So you can simply just take your hot glue and just start dripping drops of it, and that's going to go through the mesh and hold it down to the subfloor. So very, very important things. We wouldn't bring it up if people didn't call us all the time about it. So I guess that's kind of like the reason we're here today, is to try to share this information with you so you don't have to learn it the hard way. So let's take a look at the cross section of the flex roll and go ahead, and this has got a different covering than the one before it.
Yeah.
So let's go through that.
So again, starting down from the slab, we have pretty much the same cross section. You still adding the thin set. That's your adhesive to install the Cerazor, make sure it's secured. Then you simply laying down those Thermostat flex roll, installing according to the plan, and covered with a modified thin set. And then tile in the end. But that last part, you can actually do it in a one-step method or a two-step method. You can cover the Thermostat flex roll with just maybe 1/8 of an inch or so coat just to cover the product itself, and then use maybe the rest 1/4 inch or so, or whatever your tile manufacturer specifies to install the tile. Or you can cover all that in one method, one step, and install tiles at the same time.
So yeah, if you're interested in doing the one step method, which is you lay the mat down, the heating cable, then you cover it with enough thin set to start laying tiles. If you've done a tile floor a couple dozen times, you're really good at tiling, you can do that with no problem. For people that have never installed tile before, that would not be a wise choice for you to do, because we talk to people that do that and they try it on their first try and they've got a lot of tile lippage. And tile lippage is where one tile is up above the other one. It's very difficult for beginners to be able to get the tile completely flat in a one-step method. If you need more information on how that's done, just let us know. We'll be glad to help you out with that question. So now we've talked about tile. Now we're going into another big popular product in a basement floor, and that is floating floors. And that can be carpet, that can be laminate, that can be engineered wood, those type of things. Those things naturally feel a little bit warmer than tile does, right?
Yeah, I was just on the way to say that, like, that carpet on that previous picture felt like, hey, it's already nice and warm. You don't need a floor heating to it. But what a huge difference it makes when there is a floor heating installed under it. Then that room really feels just, I mean, you would never know that you're like in the basement in the winter. I mean, it just feels nice and warm and cozy there. So yeah, with a floating flooring for basement, I mean, your best flooring types would be, of course, carpet or laminate or floating engineered hardwood. With the heating product that we will be talking about in just a few slides here, with Environ product, that installation is extremely quick and easy, because you really just dealing with multiple layers, no adhesive. It's all really done nice and quick, and it's easy to replace if damaged, and it's just natural. It will feel not as cold as tile. So heating time and maybe that maximum or simply temperature of that flooring might be slightly different. You might just want to adjust it to the way you feel it.
Yeah, the thing about carpet is carpet's always going to feel warmer in a basement than tile, because carpet usually has a pad that's between the carpet and the concrete. And that pad usually has a pretty good R value, sometimes 2, 2.5. So it's naturally going to provide a nice thermal break that tile is not going to afford you. Also, when we talk about easy to replace if damaged, let's say if you lay one of these mats out and somebody drops, they have a chainsaw downstairs, and they drop the chainsaw on the carpet and it rips all the carpet up. Well, the easy thing is you can just disconnect the carpet from the carpet tacks, pull it back, pull the damaged heater out, put the heater back in, and then put it back down and stretch it back in. The same with laminate. You take laminate out the opposite way that you put it in. So you simply just take it out, lift it up, disconnect it, and click together and click apart. So if you have, for some reason, something got damaged when you installed it, you didn't notice it, and you have to go, oh, geez, this part is not working right, you can just go ahead and disconnect the floor, take it all apart, replace the product, then put it all back down again. So these products are very, very easy. You don't have to worry about breaking tiles. You don't have to reset the tile or whatever. You just take it up and put it back down. So let's take a look at how to best pair the floor heating with floating floors.
So since we're still talking, of course, about basements today, we still need to kind of fix that issue with the cold concrete slab. So for the floating installation, you want to use cork, which is natural cork material, to install over the concrete slab first. If you're planning to install carpet, you want to most likely use that high R value padding.
I'm going to stop you right there
Yeah.
because historically, hot radiant heat was done in the old days with hot water. So if you had a hot water system in the slab, you want to make sure that your carpet pad is low R value to let the heat through, and you want to make sure your carpeting is low R value to let that heat through. Well, when you're using our electric heat between the pad and the carpet, you want the carpet to still be low R value to let the heat through, but you want that pad to be high R value because you don't want the heat going down into the slab. You want it to be reflected up. So when you're buying a carpet for a basement and you're using this type of electric radiant heat, you want to specify to the person you're buying it from, we are doing this in a layer between the pad and the carpet. So they don't just sell you, okay, radiant heat, low R value pad, low R value carpet. That's not the case. You want high R value pad and then low R value carpet over the top.
Yeah, that's like what you just said, Scott, reminds me of that picture that we were talking, the thermal picture. So the higher R value padding you will have, the more of that heat, the more of these red lines you're going to see. The lower R value pad will be the eventually more just blue cold area that will be. So
yeah, and also what you want to look out for is if you've ever been to a big box store, you go out there and you say, oh, I like that carpet because it's 47 cents a square foot. Well, that carpet that's 47 cents a square foot on that big spool, if you took it off the spool, you would look that it probably has a pre-attached foam pad on the back. So you just lay it out on your floor and you cut it and it just lays there. It's not stretched in. It's not anything. You want to avoid that stuff because that pre-attached foam pad can be anywhere from 1/4 of an inch to 1/2 inch. And that foam is usually a really, really good insulator. And you don't want the heat under that trying to get through the insulation of the padding there. So it's very, very important that you don't buy that pre-attached foam padding carpeting. Now, what about floor temperature limits?
Floor temperature limits I would say is a big deal these days.
Mm-hmm.
I mean, each flooring type, depending either it's carpet or just floating laminate or engineered or so, engineered wood floor. We want to make sure that any flooring that is installed, you're running that floor heating and not exceeding those maximum temperature limits. And those temperature limits would typically be specified on your flooring manufacturer installation instructions or spec sheet, or you can simply call a flooring company and they usually would have that information provided for you. So typically that might be in the range of 80 to 82, 84 degrees. And just that can simply be just set on the thermostat, floor protection, set it to that level. This way, your thermostat will never heat the floor over that maximum set point. So simply easy to follow. This way, you still comply with your flooring company warranty and the installation instructions.
Yeah, the good thing about electric floor heat in basements under these type of limited products that have a temperature limit is with electric floor heat, we actually know the actual temperature of the floor. With hot water, it's all BTU calculations based on the temperature of the air in the room. So they don't even, I can say a lion's share of those systems don't even include a floor sensor. So they have no idea what the temperature of the floor is. When hot water tubes run into a particular room where all the tubes run together in through the doorway and then go on and spread around into the room, that doorway is going to be really, really much higher temperature than at the other end of the room.
Yeah.
So the closer the water is to the boiler, the hotter it's going to be. So to get around that, what they'll do is they'll install multiple circuits and they run them in circles and they interdigitate them and they make sure that the end isn't always at the end. Sometimes it's in the middle and they do a bunch of that. Well, that can take hours of laying those tubes out on a floor and then covering it with concrete. I can go and install 60 square feet of floating floor heating in about 45 seconds. You just roll it out, you get the cable to the wall, and you're done. I mean, that's how fast it is. So if you want a week-long job, or do you want something that takes 45 seconds and costs a lot less, this is your answer right here. This is the fastest, least expensive way to get heating in a floating floor on the market.
Great comparison.
Yeah, yeah. So it makes a big difference when you're thinking about labor costs, not only material costs, but the labor costs. Let's see, a 60-second installation of 60 square feet or a day. Which one are you going to choose? Well, it's a no-brainer. So that's what's so great about this product. You know exactly what the floor temperature is, and it's very, very quick to install. So let's talk about what these products look like and what they do and what they're called. So what are these look metallic to me. Great. Okay, should we go on to the next slide? Or what's the difference between these two metallic things going on here?
I think the first thing that I want to point out here is, just like Scott said about the previous slide about the quick installation, Environ EasyMat, the product that you see in the lower section of that slide, that's the product that literally, like Scott said, 45 seconds, and you can get that all laid out for, depending on what square footage room you're covering, because this product is provided in multiple sizes, but it's just one large rectangular pad. So, it can be from something like 2x6 or 2x10 all the way up to 5x10 or 5x15. So, if you have some larger size room, you may just, our design plan, our installation plan may show just few of these 5x10 or 5x15 pads that even that size of the area can be installed in a minute or two, and you're ready to go. So Environ EasyMat is perfect product for just some larger areas where you don't need any specific custom coverage. Environ FlexRoll is, how I would say, the brother or the sister of the Temp Zone FlexRoll. That's similar product with a similar approach where you can cut and turn that, modify that into really any shape of the area or the coverage that you need to achieve. Again, totally following that smart plan. We provide how to lay it down, but you can simply have that T-shape section or heated area covered with one FlexRoll with no problem. You can still combine the FlexRoll and EasyMat. So maybe it's just full large basement, open floor plan basement that needs to be covered. You can maybe lay down a few of these Environ EasyMats and just have some of these maybe kitchen section or a bathroom section. Or actually, no, bathroom, not a good idea, but just use the FlexRoll to cover the custom shaped areas.
Yeah, and the thing about the difference between the FlexRoll and the EasyMat is the EasyMat can be turned whatever direction you need to make it work. There is no up or down.
Yeah.
With the Environ FlexRoll, those cables you can see on the ends, those loops, those are visible because that allows you to see where the cables are, so you can cut the mesh, but not the cable. So that allows you to make that cut. But it needs to make sure that the loops that you see are facing downward. So you need to make sure that that Environ FlexRoll, as you see it right there, actually is installed upside down here. You need to flip it over so the coils are facing downward. Now, this can be used with carpet in the USA. It cannot be used with carpeting in Canada, but it can be used in Canada and the US alike with laminate, floating engineered hardwoods, and all the other types of installs. So if you are Canadian, thank you for joining us today. Pretend that you don't see this. All right, so let's talk about something that the Canadian folks can. We want to get everybody back together, the Canadians and the US customers and everybody else around the world. And let's take a look at something that can be installed pretty much anywhere, and that is our Environ EasyMat here with laminate.
Yeah, so this is a great picture. Kind of, for me, it really shows how easy that installation is, because we're going to get back to the cross-section in just the next slide or so, but that's your Environ heating product, Environ EasyMat down below. And what you really do is, as soon as the product is installed, you just start, in this case, clicking together your laminate flooring. And that's just as easy it is. You don't need to cover that with any adhesive. You don't need to cover that with anything. You lay down your heating product, start installing your flooring after that.
When you're thinking about Environ, nothing ever glues to Environ, and Environ doesn't glue to anything. So it's not adhered to anything. There is no adhering because it's floating, which means if you're using a cork underlayment, it floats. It doesn't have to be attached. If you're using Cerazorb, it doesn't need to be attached. You can tape them together if you want to. So where you have 4 pieces coming together in a corner, you can put a couple of pieces of duct tape there to hold it all together. And then you can use duct tape to hold the Environ pieces in place, but they are not supposed to be glued down. If you're thinking about thin set, if you're thinking about glue, this is not the product for you. There is no thin set used here. There is no glue used here. So let's go ahead and take a look at this one, and everybody can look at this one. So describe this to us.
So that's our laminate floor cross section for the installation with environ heating. So concrete slab is, of course, our first step, first layer. We talking about that today in our webinar. Then we want to install the cork.
Why do we use cork instead of Cerazorb here?
So cork, comparing to Cerazorb, cork is a little bit thicker material. It's just about 1/4 of an inch thick, comparing to the Cerazorb that is only 3/16 of an inch thick. So it's really, if we talk in millimeters, it's just about millimeter or more of a difference. But the cork with that 1/4 of an inch thickness is ideal because your factory splice and that cold lead that will eventually be used for the environment heating product
runs off the edge here.
Right, the runs right out of the edge to go all the way to your thermostat. We want to make sure that that cold lead that is 1/4 of an inch thick, not going to create any sort of bump, any sort of uneven section on the floor. So the trick to that is just cut out a nice channel in the cork. It's 1/4 of an inch, run that cold lead through it. Flooring going to lay down on that nice and flat without any sort of issue.
Yeah, and watch a video. We have a video that shows exactly how to do that on our website. So check that out if you have because you also, not only do you have to channel out the places for the cables to get back from the mats, you also have to get that thermostat sensor channeled in there too. So we cover that in the video too. So once again, this cross section is for US only.
Yeah, so this is our carpet floor cross section, and in this case, we were talking about that earlier. Over the concrete slab, you would just start with the carpet padding. Make sure it's a nice high R value padding, so we will kind of save as much heat onto that top surface, and less heat going to be transferred down into that cold concrete. So carpet pad goes down first. Environment floor heating goes straight on top of that, all floating, and then eventually the carpet will go on the very top. The trick in this particular installation would be to make sure that you have enough perimeter, typically a foot or so, for the carpet stretching. You want to make sure that the installers, the carpet installers who will stretch the carpet in the very end, these tools they use are having really those sharp teeth. Mm-hmm. So you want to make sure they're not going to just put that in, go through your carpet and straight into a heating product. You want to make sure there's that perimeter where they're going to stretch, where they're going to use the tool is free of heating element.
Yeah, so you always want a perimeter that is not heated with carpet to allow those carpet stretchers to get their teeth in and pull it. Otherwise, those teeth can go right into the wire. Also, the great thing about underlayment like this carpet padding is usually the 6 to 8 pound rebond that you see on spools, usually the cheapest stuff, that stuff usually has just about the best R value too. So it's a great thing because it's probably the least expensive underlayment, and it also usually has the highest R value, especially if you go up to 1/2 inch. You can get really good R values using regular old rebond. And that's what's so good about installing a carpet this way in the United States. So we talked about all these products and where they go in. Let's talk about how we control them. So I just noticed that thermostat is black. That's one of our brand new black thermostats that's available. So that may actually go with your decor a little bit better than the white. So that is available. So let's go ahead and take a look at our next slide. And to be able to control the temperature, we need to know what the temperature is. So for us to know what the temperature is, we need to make sure that we put this floor sensor in. What do we need to do before we do anything with this floor sensor? What do we need to make sure our meter has, and how do we test it?
The multimeter that we were talking on those first couple of slides, we want to make sure that meter has the 20K ohms scale. And if you're getting one of those meters with a manual selector, like the one we recommended, those meters would typically have that 200 scale for testing the heating product and 20K scale for testing the sensor. And the reason we want the 20K scale is because the sensor, it just has a thermistor in the very end. So the resistance of that will vary depending on what the temperature it's exposed to right now. So that sensor, that resistance can read from something like 6,000 ohms, which is 6K ohms, all the way up to like 18,000 ohms, which is 18K. So that's where the 20K scale comes from. So pretty much as long as you're testing the sensor and as long as your resistance is roughly in that range from 6K to 20K or 18K, you should be fine. That's just really what we're looking for. And of course, the next step would be to place that sensor in the right spot. As you can see here on the picture, we want to make sure that the sensor tip, that black tip, the thicker portion at the very end, is positioned right between the heating wires, because that's going to be your perfect spot with that best average temperature. You don't want to have it right on top of the wire or right next to the wire, because it may read 100 degrees while the floor is maybe only at 75. So
this does have a little bit of a lump too. So if you're doing carpet or if you're doing laminate, this is going to be poured over with self-leveling. But if you're going to be doing carpet or laminate, what we suggest is that you actually take this and kind of route it out a little bit for it to sit down and get in a relief area. But you don't want to make sure, you want to make sure it's not sitting directly on the concrete.
Oh, yeah.
So if you put it on the concrete, your flooring will always be out of whack. It needs to be just a little bit taken out. So if there's a concrete slab under there, that it's not touching, but it gives you enough relief that you can get it down there and not have to worry about feeling that lump every time you walk on it.
So in that last bullet point, we always say here, and we always talk to the customer, avoid any spots with that direct sunlight, because that spot will always be warm, can just show this, can bring that temperature sensor up to 75 degrees or 80 degrees and just send a signal to the thermostat like, hey, it's nice and warm here, don't turn on the system, while in reality, the rest of the floor is just at 65. So we want to avoid any spots with direct sunlight. The same thing on the other end, we want to avoid any areas that may have, for some reason, colder temperatures. Maybe it's right out of the exterior door where the floor will always be just naturally colder because, the door is being open multiple times or so. So just pick that nice, perfect average spot where the temperature is going to be more or less in those average numbers.
And this can go, the thermostat can go on an exterior wall, unlike a thermostat for your HVAC system, because once again, we're not taking the temperature from the thermostat itself. So if you put it on a cold wall, it's not going to affect the reading because the sensor is out in the floor. So there's going to be some times where naturally you're going to try to put it on an interior wall, but if that's not available, you don't have to worry about putting it on an exterior wall as long as it's on the inside. Last thing you want to do is mount this outdoors. You don't want to do that. So let's talk about the different thermostats and what they do and why it may be better if you have a really expensive floor like hardwood. Why would it be better to use the least expensive thermostat? So let's go ahead and go through these.
So one possibility here, since we're already talking about hardwood, there would usually be some sort of temperature span, some temperature range for the flooring, like, give me an example, Scott. 65 to 75 or so.
No, what we find out with hardwood floors is that the flooring manufacturer says during a 24-hour span, the temperature can only be plus or minus 1 degree, or plus or minus 2 degrees or 3, whatever it is. What we've done in the past historically with these programmable thermostats is we have them come on to a warm temperature in the morning, go down 10 or 15 degrees during the middle of the day, get 10 or 15 degrees warmer at night, then overnight get 10 or 15 degrees colder. You can't do that with hardwood. Hardwood has to stay the same temperature all the time. Otherwise, the pieces of wood are doing this all the time, and you don't want that to happen. You want that to get to a specific temperature and leave it there for the whole year. Well, if we know that we can't program hotter and colder periods in that 24-hour span, we know that we don't need this because it's programmable. We don't need this because it's programmable, or this because it's programmable. All we really need is this. We set it, and the thing is, when you're doing a hardwood floor, is you have to commission it and decommission it, which means at the beginning of the heating season, you go up 2 degrees on day 1, go up 2 more degrees on day 2, up 2 more degrees on 3 days, and so on until you get up to the 83, 84, whatever that maximum temperature is. So once again, that's why the most expensive floors are usually hardwood, and they use the least expensive thermostat. So what else do we need to worry about with these?
So yeah, I mean, Entrust, which is our non-programmable thermostat, and that top left image here, that's perfect for a hardwood floor. Enhance is just a basic standard programmable thermostat. You can set up those schedule and different time periods and adjust the settings. Inspire Touch is my favorite. Super easy to use, super easy to set up. Really, the whole setup and even preparing the schedule in the unit will really, if you just click on that, may take a minute, maximum 2 minutes, because it's one large touch screen. You're not dealing with any physical buttons or any combinations here. You just tap into it just like on your smartphone, and you're ready to go. It's all set up. And if you need that Wi-Fi connectivity, if you need that remote control from your smartphone or from your computer at work or something, you can get an Inspire Touch Wi-Fi. That's where you can, you're driving back home or you're driving to your vacation house or so, you dial up the temperature and, it's all warming up. So you really, on the other end, you kind of making the system economical. You don't need to just run it on that strict schedule and, it's 5:30 p.m. It's already warming up, but maybe you stop by for a dinner and your system is just running for 3 hours and it's taking that operation cost.
Right. So what you need to keep in mind is we're talking about basements that are usually not inhabited all the time. So if you're not inhabited all the time, you don't have to worry about a daily program. You only really want it to be warm when you're down there.
Yep.
So once again, that's where this comes in great, because when you get down there, you change the temperature and you keep it there until people go home for the holidays.
Sure.
And then you turn the system back off again. There's no need to program it. You set it and forget it. So a lot of the stuff that we've been talking about up to this point with the installation can be done pretty much by anybody, except we always suggest that when it comes to hooking up this thermostat to the main power supply of the house, that an electrician who's licensed and insured does this part. And that may be required by your local code also. So whenever you're doing these installations, always make sure when you're doing them that you're complying with the local code. Some state codes may not allow you to lay out the heating cable. Most of them do allow you to do it, but there are a couple that say, no, that's got to be done by an electrician. So always check and see what your local building codes and your electric codes require when it comes to these kind of systems. So do we have any questions? Victoria asked, what if I have cracks in my concrete slab? Will it affect the installation? Well, the thing is, in your concrete slab, there are two kind of different cracks in a concrete slab. One kind of crack is where they just come apart. Then there's the other kind that does this. These that do this are problematic because it means one section is moving independently of the other. And the problem is you don't want wire running through, between this.
Across that whole thing, yeah.
Yeah. So if your concrete is cracked and it's just separated, that means it's probably done moving. And what it's done is a lot of them do that. So once it cracks apart, then you'd want to definitely use Cerazorb over the top of it, because Cerazorb is going to uncouple your tile from that crack. So even if your crack does open up more, the Cerazorb has got a 1/4 inch crack suppression that will allow the subfloor to pull apart even a 1/4 of an inch more before it even gets translated to the floor. So that's a great question, Victoria. We had a couple questions that were very, very similar, like how efficient are basement floor heating systems with basements that are walkout with windows? And can this be used as a primary heat source? We get that question all the time.
Popular question, yeah.
Is there a membrane that minimizes the heat loss for heating the slab? So let's talk about that.
Yeah, so I think the general answer for the first part of the question about, is it efficient or can it be used as a primary heat source? The best way to kind of find out the final correct answer to that question is to run the heat loss calculations for that particular area or for that particular room or the whole basement. And what that simply means, we have that calculator available on our website. Anybody can easily access that and use it. You kind of punch in the information about how big that area is, what insulation values you use, what wall insulation you have, maybe how many windows you have, what type or what's the R value of those windows are. So pretty much you just put in the information on how well insulated your basement is, and the system will give you an answer on what's your heat loss is. Let's just say it's 3,000 BTUs or so. And if the floor heating can provide more than that, that means the system going to be just fine for a primary heat source because it's going to provide more heat than the basement is losing.
So there are things that we call heat loss monsters. And since we just got done with Halloween, you want to think of heat loss monsters as the things that will keep you from being able to use this system as a sole source of heat. What is a heat loss monster, you may be asking yourself right now? Heat loss monsters are things like skylights, exterior walls, exterior doors. So I think this leads specifically to Victoria's question, like basements that have walkouts in them. Well, first of all, we know the walkout's got an exterior wall.
Yeah.
And we know the walkout is going to be serviced by an exterior door. So you've got a couple of big heat loss monsters that you're trying to get away from. What are a couple other heat loss monsters that you can just see them when you picture them in your head as having fangs and big claws?
For some reason, for me, the kind of the big monster I see, it's those maybe older constructions with no edge insulation or really poorly insulated walls. That's where it's going to affect it a lot because eventually, again, we're talking about that kind of.
Yeah, but why worry about those? Because those rooms have fireplaces.
Right.
But fireplaces are one of the most notorious heat loss monsters that there are, because if you don't close that flue, that heat that you're making goes right up the flue, just like it escapes through skylights and that sort of thing. So if you had to picture the worst possible scenario of a space would be 4 exterior walls,
yeah,
big walkout doors in each wall, skylights throughout, really high ceilings with a bunch of fireplaces. Those are, you've never really thought that way. I mean, it's, you think about it, you think about what lets heat escape. Those are our enemies because we want to keep the heat in. That's why new houses that are well insulated usually are able to use sole source heating in the floor quite often. But in older homes where all these things, all these heat loss monsters are, it's very difficult to use that as the sole source of heat. So hopefully we kind of get you the idea of, you know, what you're going to look for in a room that has a good success chance and one that's going, oh, well, this has got a bunch of monsters that I don't know if I can deal with. I deal with a monster under my bed every night. So that's what I have to try to fall asleep to. But the thing about a concrete slab is it's a heat loss monster too. It's trying to pull all the heat down. So the first thing you can do is you can put cork or Cerasorb over that floor, and that will mitigate that one. So we had one more question, and what types of flooring cannot be heated? Heather asked that.
So really any flooring material, or maybe should say flooring manufacturer that specifically prohibits radiant heat of any kind, that's eventually, you know, that's where you need to comply with the flooring manufacturer instructions. But as far as we know, really any flooring can be heated as long as it's all approved and designed to be used with the radiant heat. So,
and it doesn't have a high R value.
And yeah, no high R value, no, you know, extreme thicknesses where the heating system just physically cannot transfer all that heat to the top surface.
So the first question, when I started here a decade ago, is people would ask, can I use this type of product? Well, a decade ago, a lot of people didn't know what the R values of floorings were. So you'd have a manufacturer go, well, we don't know what the R value of that is. But if we saw a pre-attached pad, that was a bad signal because a pre-attached pad is foam. Foam contains air. Air is a good insulator. So we would always say, hey, you know what? Stay away from the pre-attached pad. But now we know that a lot of companies are making product that have an R value. So the first question we're always going to ask is, what's the R value of the flooring? If the R value is R1 or less, sure, go ahead and use it, because no matter what it's made of, as long as it has an R value of 1 or less, that's a good combination. If you have a product that has an R value of 3, you don't want to heat that. It's probably not going to be allowed to be heated under anyway. So those are some of the points that we wanted to bring. And those were great questions. So thank you to Heather, to Diane, and to Victoria, and to Misty. Thank you so much.
I think we still want to add real quick with the second part of the question from Misty.
Yes,
I think we forgot that during the webinar, during the environment portion, but to answer that second part, the question was what happens if the basement floods. So let's just say if it's the flooding in the basement that has laminate flooring, let's say, for example, that's where we use that environment system, the kind of aluminum metallic looking floor heating product. that environment product is water resistant. So what you want to do, you want to dismantle the flooring first, dismantle that whole flooring assembly, perfect cross-section, yeah. And then you want to just let the components dry. So, whatever the lower layers, the environment product, and maybe some underlayment or so.
Take it all out and let it dry off.
Take it all out, let it all dry. Then you want to test the product. That's where we want to understand, was there any internal damage, any internal shorting to the system? And if it's all good, there might be a perfect timing to lay it all back out, maybe just temporarily, test it, run it. If it all heats up, if it all tests good, you should be good to go to install the flooring again.
Yeah, if you're having a flood, you want to get these layers taken apart anyway to inspect to see if there's any damage to them, not only just the environment, but remember, if the product below and if the product above starts to fail, it will take the heating system with it. So the heating system is very resilient until the parts below it start breaking up and the parts above it start breaking up. Then you have to worry about the condition of the heating. So thank you, Heather, for your thanks. So you get a double thank you for chiming in there. And I think that does it for the questions section. So make sure you join us for our next webinar. It's how to get an instant radiant heating quote. So you can do that with us on Thursday, December 13th on 1 p.m. That's Central Time. So make sure you join us for that. That'll be scintillating, I'm sure.
That's my favorite.
Yeah. And then our monthly promotion, it's November for a while still. So for a limited time, you get free ground shipping through the 30th. So while right after you wake up from your nap on Thanksgiving Day, it still gives you a few days left to get those orders in for free ground shipping. And, when this time of the year comes up, it's always a good idea to get those in as soon as you can, because you know what happens this time of year. The shipping dates start getting longer and longer. So you want to make sure that you are able to take advantage of that sale. So we also value your feedback. You're going to receive an email shortly asking about your experience during this webinar. We appreciate your comments and suggestions. If there's something that you want to see us cover, please let us know. Also, if you're wondering, gee, I wonder if they covered that ever, go into our website, and on our website, you can see all of our webinars are there. So all the recordings are there. You can see what's covered. So if we have talked about it before, you'll be able to watch that webinar. And if we haven't talked about it before, please let us know so we can go ahead and get that one slated in. So you can also contact us whenever you want to. We're here if you have any questions that we didn't get to today. You can call us at 800-875-5285. You can email us at the emails there. And you can also check us out on the web. And obviously, you know how to use the internet now because that's how you're watching, right? So we're just going to assume that you know where we are. We just remind you that we are out there with our social media accounts. You can check us out on Facebook and all the different places. So make sure you look there. And we hope to see you next time. And until that next time, stay warm
and be radiant.
See you later, everybody.
See you.